What is this thing, you ask? Some of you refer to it as Satan's eyeball, but this is actually the unit circle. We're going to be talking today about how you can find one piece of the unit circle, and that can essentially give you every other piece. I would say the worst thing you could do is just try to memorize every piece of information. That's not going to be as helpful as understanding the concepts behind it. So we're going to talk about this first quadrant and how you have all the information you already need to solve this. So let's do the easiest part first. Let's talk about the degrees, okay? Right here, we can have 0 degrees, or if we go all the way around, that's going to be 360. Now that's the nice part, not too bad. So once we start climbing, we're going to climb 30 degrees, 45, 60, and then to our 90. Now these are very easy points in a test, so please don't ever leave this blank. And the reason we're using these exact degree measurements is that they will actually help us by finding our right triangles that have special characteristics. And that's actually what I'm going to use in order to come up with our coordinate points. But we'll get there in a little bit. Let's fill in some other information. So we know that all the way around the circle is 360 degrees. We also know that it is 2 pi. So when we start off with our pi or our radian measurements, we're either at 0 or 2 pi. Now, we're going to refer to this as different pieces of the degree, but we're going to use that to find the pieces of 2 pi. So if I had 30 degrees, that's 30 out of the 360, right? So that's essentially 1/12. So if I have 30 of 60 is 1/12, that means I have 1/12 of the full 2 pi. So if you think about that, 1/12 of 2, so take 2 times 1/12, you get, that is pi over 6. Okay? Now, if 30 is 1 pi over 6, then 60 is 2 pi over 6, which means this has to be pi over 3. Now, 90, everybody should know this. If an entire thing is 1 pi, then half of it is just half pi. Now the last one, 45 degrees, well, keep in mind, if 90 is half, 45 is half of 90, that's just pi over 4. So filling in the degree and the radian should be pretty basic and pretty quick. Now is when we have to understand the concepts behind this. I want you to see something. If we take this 30 degree, okay, and I'm just going to do a little cut here. Do you see that I've just made a 30, 60, 90 triangle? Let's pull that out. Let's pull that out really quick. Now, that's the worst triangle you've ever seen. Don't judge. Now, what I have here is my 90 degree. I know that this is a 30 here, which means this is a 60. Now, the unit circle assumes that we always have a radius of 1. So what I can do now is my knowledge of a 30, 60, 90 triangle. 30, 60, 90 has these properties. If we know the short leg to be x, that means that the hypotenuse is 2x, which means my long leg is x times square root 3. That's a property that needs to be known already. So if this is true, that means that if I know my radius is 1, my short leg is 1/2. And my long leg is square root 3 over 2. Now, if you're confused by that, take 1/2 times root 3, you get I'm right. So let's understand what's going on here. You just told me that if this is 1, the long leg, or the distance from this point to this right angle, is square root 3 over 2. The height here is 1/2. You have just given me your first coordinate point. How do you get to this point? You would go over root 3 over 2 and up 1/2. Knowing the right triangle properties gave you that point. And here's the beauty of it. See how that's a 60? You see how now the sides just changed? You would go over 1/2 and up square root 3 over 2. Using these special triangles is really going to help us find the coordinate points around the unit circle. Now, let's do the easy one really quick. If it's 90, well, we just went 0 and left or right. Use the correct marker. And we went up 1. Okay, last one. 45. Well, good news for us. We have a 45, 45, 90 triangle as well. If I pull this piece out, I now have my 45, 45, 90. I know this is 45, which means that's 45. My radius is still 1. Now let's think of what we know. In a 45, 45, 90, we know it's isosceles, which means this is x and that's x. Then this would just be x square root 2. Well, x square root 2 is equal to 1 now, which means my sides are square root 2 over 2. That's just solving algebraically. So look at what we've just stated again. I would go over 2 square root 2 and up 2 square root 2. That is exactly what your coordinate point is here. And this side, we forgot at the beginning, we go over 1 and up none. You have now just filled in the entire first quadrant of the unit circle. Now I'm only going to do one more quadrant for you to show you how easy this is. Watch how quick you can fill things in. Notice how you went 30, 30, 30, and then there's a 45, 45. So let's keep this trend. 30, this represents the 45, so keep going. Another 30, another 30. That is the worst 8 you've ever seen. Let's rewrite it. Now, this was 45. 45 more than 90. You see how quickly you can do that? Let's do the pies. Well, it was 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi. Now keep in mind that's 4/6, which would give me a reduce 2/3 pi. So that was 4/6 pi, 5/6 pi, 6/6 pi. It's pretty nice. Going by quarters, 1/4, 2/4, 3/4. The radians move just as fast as the actual degrees. Now, here we go. This is one of the nice parts about using reflections. If I know this is 1/2 to the right up radical 3 over 2, this is just negative 1/2 radical 3 over 2. You're going to see a pattern here. Flip around the axis, negative root 2 over 2, positive root 2 over 2. Negative root 3 over 2, 1 over 2. Negative 1, 0. So all I did is reflect it around the y-axis. And then once you're done here, flip down there. Once you're done here, flip down there. Quick tutorial on unit circle, how to fill in the missing information, and use the concepts here to fill in the rest of it. Hope it's helpful.